nitrogen and impurities in the fuel and air. Because of the pollutants, we get a lot of things whenever you are staying back. You are irritating of eyes, irritating of nose, and bronchitis, and a lot of things. Because whatever the air you are inhaling it, this air will gives you a lot of damage to your parts, particularly eyes. Whenever you are traveling in a cities, particularly if you are traveling in a AC car, you may not see it. And suppose you are traveling in a open air, and you are going to get a lot of pollution because you will get a lot of dust on your face and a lot of these things. That particles will go to in your eyes, and eyes will get irritated, and the life period of this, and a lot of problems will come into eyes. Then whatever the air is inhaling it, that will use bronchitis and other things. And sometimes if you are little bit weak, you may get unconscious also in the road itself because of the pollutants and all other things. It goes inside the your breathing, then it gives a lot of problems and irritating of nose and irritating of eyes. A lot of things will be coming through these pollutants. Either it's a petrol pollutions, SI engines or CI engines. Any internal combustion engine, either any mode of transport will get pollutants. And engine emissions are classified in two types. One is exhaust emissions, another one is non-exhaust emissions. Exhaust emissions means whatever the combustion will be happens, and through this combustion, what emissions will be coming. And this, the other thing is non-exhaust emissions. Without exhaust also we will get some emissions. We will discuss it one by one. Particularly, we will concentrate about the exhaust gas emissions. And now we have a carbon monoxide, and CO will be there. The unbound hydrocarbons and oxides of nitrogen NOx, oxides of sulfur SOx, particulate, soot, and smoke. These are all the common phenomena: carbon monoxide, unbound hydrocarbons, oxides of nitrogen, oxides of sulfur, and particulate, soot, and smoke. Because diesel engines will see more smoke. That smoke will have a lot of particulates matter. Soot will be there, and while seeing it the exhaust. And petrol engines normally SOx and NOx and carbon monoxide also will be coming in petrol also. In this, you maybe get this leaded and unleaded petrol also. Once upon a time, we have a leaded petrol. Later on, we have a few changes in the bunks. They removed the lead content because it's very dangerous. After getting up the combustion, the lead content will be going in the exhaust gases, and whatever the exhaust gases you are inhaling it will the lead content will goes inside the mouth and inside the nose, inside the eyes. You will get a lot of health issues and all. Then government has taken the decision 10 years back, and they have removed the lead content in the oil, petrol, and diesel, yeah, while pouring into the petrol in your bikes. And these are the exhaust emissions: carbon monoxide, unbound hydrocarbons, oxides of nitrogen, oxides of sulfur, and particulate, and soot and smoke. The first four are from the both SI and C engines, where last two are mainly from the CI engines. And the last two will be having oxides of nitrogen, oxides of sulfur, particulate, soot, and smoke. Then non-exhaust emissions. Now we are talking about only after combustion, after burning of anything. You burn the wood, after you burn anything, you will go to burn the paper or something. Whatever the thing will come out from the smoke and all, that also will be having the emissions. Non-exhaust emissions, whenever you may be seeing the fuel tank, emits the fuel vapors into the atmosphere. Basically, in petrol tanks and two-wheelers and four-wheels, you will see a small hole on the tank cap. That cap will use that petrol vapor. Petrol will be highly vaporable. You have the vapors will be coming out from the petrol tank whenever you are storing it, wherever we are keeping it outside the environment, and it is exposed to the sun rays and all. Because of the heat and all, we'll get the evaporation will have happens. These vapors will be coming and mixing into the vapor atmosphere, and we are going to get it. And carburetor also gives out the fuel vapors whenever you are mixing of it, fuel and air, the carburetor of petrol. Spark ignition engines, sorry. Spark ignition engines, the vapors also will be having fuel and air vapors will be coming out, and also will be. They have crankcase ventilation, it emits blow by gases and fuel vapors into the atmosphere. Particularly in crankcase blow by will be happening in the two-stroke engines most, and four-stroke engine is very less. And crankcase by way loss will be there. And because of these exhaust gases, sometimes it's coming down and spraying over it, and it will mixing with the oil and coming out the way of waste, and we are also going to get the emissions. And if you compare it and the fuel mode, fuel equals ratio, then amount of emissions in the exhaust flow. We already talked about the lean burn combustion and rich combustion and stoichiometric air fuel combustion. Because the stoichiometric air fuel combustion means the correct mixture of the fuel will be going inside the engine or getting out the combustion. Sometimes your engine is not starting. You're going to give a rich mixture. Suppose your engine is going very higher, faster speed, and lean mixture is sufficient to operate it. Particularly in the SI, spark ignition engine, homogeneous mixture will be entering into the fuel. Whenever your two-wheeler is not starting, you are going to operate your choke or initial starting. Or any car also you are going to operate the choke mechanism for operating of the engine. For 2-3 days you are not starting the vehicle and all. And because of this, the engine may not be starts. You have to give the rich mixture. And rich mixture also will use a lot of pollutants and all. If you see the diagram of this you are seeing one is a crank angle diagram where you have P theta diagram. You are going to see this. And the peak pressure where you have a dotted, that is called the stoichiometric air fuel mixture. And if you see this side, you are going to have a lean mixture. Lean mixture will have less pollutions and all. If you have go to the rich mixture, when the rich mixture goes is initial starting, whenever going higher speeds also, you are opening the accelerator and giving more throttle opening. If you give more throttle opening, more fuel will be going inside and combustion rate will be decreasing because of the operation of the piston and all. And because combustion rate will be reduced, once the combustion rate is reduced, unburnt hydrocarbons will be seen very heavy in this rich mixture. And we have NOx and we have SOx and CO also will be there. And we have these are all things will be happen in the environment of the spark ignition engines. Now, if you see this, the same thing, NOx, CO, HC concentration and equivalence ratio you are going to see, and CO will also will going to see from 0 to zero point 0.8, and here we are going to see this HC combustion. And if you take the same thing and the mixture, because here in diesel engines we fuel and air will mix it inside and going it. We don't say that a rich mixture or lean mixture. The mixture will be going inside and getting out. The percentage of oxygen is good, then the combustion rate is more in any petrol engine or diesel engine. And you can see these HC emissions and NOx emissions. And whenever you are going at higher speeds, and because of the more fuel will be going inside, inducting inside, and you are going to get the more pollution. And particularly, first thing we are going to discuss how the hydrocarbons and what is the nature of the hydrocarbons, how it will be. It is a strong function of air fuel ratio, which the fuel rich mixture, there is not enough oxygen to react with the all the carbon resulting in the high level of hydrocarbons and carbon monoxide in the exhaust products. This particularly true during the starting when the air fuel mixture is purposely made very rich. Basically, whenever your two-wheeler is not starting, you have to operate the choke. If you operate the choke, more fuel will be going. That is says that its rich mixture is going inside or getting of the combustion. And whenever your throttling is opening and all, you are going to get the suppose the oxygen percentage is good in your air and combustion rate is good, and you don't get more hydrocarbons. If the combustion rate is less and combustion, then you are going to get more high level of hydrocarbons and carbon monoxide in a rich mixture, particularly rich mixture and high speeds. This is particularly during the starting, and the air fuel mixture is purposely made for the very rich. The combustion chamber geometry and gasoline operating parameters also influence the hydrocarbon component of the spectrum. Basically, the designing of the combustion chamber of the spark ignition engines and carbon compression ignition engines, the designing of the combustion chambers also, we have seen the different types of designs will be available, P-head engines, L-head engines, F-head engines and all. And the piston crown also we are going to have a lot of designs, a lot of models we are going to have. In this, the bowl of the combustion also will get the effect of it getting up more combustion. The causes of hydrocarbon emissions from the SI engines are the causes of hydrocarbon emission from the SI engines are incomplete combustion. And what we are talking is the percentage of oxygen is less, automatically you will get an incomplete combustion. And we have that is the number one where we are going to have. I talked about the any engine, petrol engine or diesel engines. Particularly, what happens is the oxygen percentage is less, and you are going to get the incomplete combustion. This is 40% or 30% or the 50%. Depending on the percentage of oxygen is available from the environment, outside of the environment, and it succeeds and mixing it and sending it to the inside the engine. That we call it as incomplete combustion. Previous volumes and flow in previous, and volumes, how much the volume rate or what is the jet size, how we are going to inject it. That is also will gives an effect to this environment. Leakage path and exhaust valves. Leakage path of the exhaust valve. The exhaust valve will be sealed with the concealed with the gaskets, but still we have some leakages and all. That also will leads to the getting of the combustion. Valve overlap also will getting when the valve overlap will happens, when the two valves will be closed, we are going to get valve overlap. The timings are very important because this will be operating with the cam arrangement. We already talked about the camshaft and crankshaft. While talking about the crankshaft rotation will be suppose 1000 RPM. Your camshaft rotation will be exactly half of 500 RPM, and these cams will be operating over valve arrangement and injection timings of the injector or the spark plug spark plug uh, spark will be given according to the timings, and then the camshaft knife edge will be follows, and automatically Darshi, if you're అది కాదు. ఇదేనా బ్యాటరీ. And what happens because of C engine operating with an overall fuel leakage of fast and exhaust valve overlap, and deposits and walls. Because carbon deposits may also will leads to have the problem of around the cylinder walls. Because cylinder sleeve or the cylinder liner, we're going to deposit the carbon deposits on the, still the piston will be cleaning with compressor rings and oil rings and all. Still we have the some deposits will be there on the on your sleeve, or what we have is cylinder liner. Oil on the combustion chamber walls, because the cleaning purpose we are going to have two oil rings and two compression rings. It will again it's cleaning it. Still we have some lubricating oil will be there on the chamber walls, and that also will give the unburnt hydrocarbons. Because of C engines operate with an overall fuel lean equivalent ratio, C engines have only about one-fifth the hydrocarbon emissions of an SI engine. In general, C engine has a combustion efficiency of about 98%. This means that only about 2% of the HC fuel being emitted. Basically, spark ignition engines will give the more hydrocarbons, and carbon monoxide will give from the petrol engines or spark ignition engines. Spark ignition engines. Spark ignition engines. But in combustion engines, what we are going to get is basically uh, we have particularly we have a smoke, and smoke also uh, okay, we CA engine has a combustion efficiency of about 98%. This means that only about 2% of the hydrocarbon fuel is emitted. But particularly in diesel engines, whatever the smoke we are going to get, that particulate matters are very dangerous, and this will be having a lot of pollutants, and this will be very harmful to the persons where we are having to inhaling of these things. And we have a carbon monoxide, and the carbon monoxide CO emissions. COs, because we talked about the hydrocarbon emissions. Now we're going to see the carbon monoxide. These are also very dangerous emissions. It is generated in an engine when it is operated with the fuel rich equivalence ratio. Basically, whenever you are going higher speeds and higher loads, and you are going to operate it, you are opening more throttle, more fuel going, and you are going to have a rich mixture when the vehicle is starting. That also will create the carbon monoxide emissions. When there is not enough oxygen to convert the all carbon CO2, because the oxygen percentage in the air is very much required for the getting of a good combustion and reducing of CO and C emissions. Some fuel does not get burned, and some carbons end up as CO, because whatever the fuel is not burnt, that will be having two forms. One is hydrocarbons and carbon monoxide. These two are very dangerous for the combustion point of view. And these are two are very harmful if you inhale it. And I told already, a lot of health issues will come in for the persons who are staying nearby the pollution area. And typically, the exhaust of the engine will be about 0.2 to 5% carbon monoxide. Basically, if you take in percentage, the exhaust of such engine will be about 0.2 to 5% of carbon monoxide. Not only CO considered as undesirable emission, but it also represents the lost chemical energy. Basically, if you unburn, because unburned thing will be there, that is means whatever the chemicals will be formed inside the combustion chamber, but complete chemical energy will not burn and will not give more energy. That is also we have mixing of the fuel and air will have the problem in this. And maximum CO is generated when an engine runs rich. HC and CO will be having more in rich fuels. Rich mixture is required during starting or when the accelerating under load. And the rich mixture is required during the starting or when the accelerating under the load conditions. Poor mixing and local rich regions and incomplete combustion will also be the source of CO emissions. Already I told in the different classes while discussing this, combustion also will be the main problem. We have a pollutants. Then oxides of nitrogen. These also pollutants. Exhaust gases of an engine can have up to 2000 ppm particulate matter, ppm of oxides of nitrogen. Most of this will be nitrogen oxide, NO, and with a small amount of nitrogen oxide, NO2. There will also be a traces of other nitrogen oxygen combinations. These are all grouped together NOx emissions, where X represents the some suitable number. NOx is a very desirable. Basically, emissions will be coming in different things will be coming HC, CO, and NOx. We call it as NOx emission. This will be having a small amount of nitrogen percentage, and you have nitrogen oxide oxide, and nitrogen diode will be there. Dioxide, nitrogen dioxide will be there. These two will be having the representation will be having NOx emissions. In our emissions, we call it as NOx emission. It is very undesirable emission, and it also causes the health hazards. Well, released NOx reacts the atmosphere to form a ozone layer, and it is depleting the ozone layer also, and is one of the major causes of photochemical smog. Photochemical smog also will be happening with NOx emissions. Not only we are not talking only one, not only automobile engines, we are talking about the industries, we are talking about the different things, and different things will have the different pollutants, and whatever the pollutants, wherever you have a burning issue will be there, their combustion will be there. Because of combustion, will get a lot of exhaust will be there. That exhaust gases of any of things, either industries or automobiles or whatever you are burning it simply also are going to get these things will be covered from this thing, and this will be very harmful to the atmospheric region of ozone layer. At low temperature and atmospheric nitrogen exists as a stable diatomic molecule. At the low temperature, atmospheric nitrogen exists as a stable diatomic molecule. However, at very high temperatures, that occurs in the combustion chamber of an engine, some diatomic nitrogen N2 breaks down to the monatomic nitrogen N, which is reactive. Basically, if you see the NOx emissions, we have different forms of NOx emissions will be coming. The different reactions will be having with different temperatures and outside the environment. That is called, we are seeing NO and NO2, nitrogen oxide and nitrogen dioxide, and we are going to have a nitrogen also, N2. And these are all very reactive with the atmosphere and environment, and it causes a lot of damage to the ozone layer. And the significant amount of N is generated in the atmosphere range of 2500 to 3000 K that can exist in an engine. Maximum NOx is slightly lean equivalent ratio of about 0.95. At this condition, flame temperature is still very high, and in addition, there is an excess oxygen that can contribute with the nitrogen to form a various oxide. Basically, if you have any engine, The cooling system is very important. The cooling system is not proper. Your engine may be series of all will be having a metal. Every metal may have a temperature limitations and all. But now we are presently we are having very high-end engines will be coming with a temperature range of very high, because previously we have a 100 degrees temperature is there for the coolant as a water, but now we are mixing with another synthetic resins to the coolant, and we are having a temperatures of very high temperatures. We are having it, the combustion temperatures or engine temperatures or whatever we are having, all will be increased because of the cooling system has improved a lot for getting out. Because previously we have a only maximum is 100 degrees and water will be evaporating very easily. You know the boiling point and melting point of water because of the radiator heat, and you have to stop the engine, you have to wait and you have to go. But nowadays, all engines will be having a coolant system and all, and wherever you have parts will be heating up, all parts to be cooling very easily, and it is more exposure will be there, atmosphere cooling, and the water cooling will be there, the cooling will be there, and they're going to get very cool. Because of high temperatures also, we're going to get lot of temperature ranges will be coming out from the engine. That also will having a lot of effect of the pollution. In addition to the temperature, the formation of NOx depends on pressure in the air-fuel ratio. Because we are already talking about the air-fuel ratio, and if the air-fuel ratio is increasing more, and the combustion rich mixture will be going inside, getting up the unbound hydrocarbons. And in this, because CO and HC later on we have only NOx will be coming out. Combustion duration plays a significant role in NOx formation within the cylinder. Not only having the problem, and from this unburnt hydrocarbons also we will be having a lot of things, and a lot of chemical reactions will be happening and photochemical reactions. For that, we are going to get through exhaust, lot of NOx emissions will be coming out from the engines. And these are about the SI engine, particularly in SI engine. These are very high, and if you see it, particulates, the exhaust of particulate matters will be coming through compression ignition engines. In these compression ignitions, the exhaust CI engines contain solid exhaust CI engines contain solid carbon soot particles that are generated in the fuel-rich zones within the cylinder during the combustion. The exhaust of a CI engine contains solid carbon soot. Or soot will be soot particles will be there, and these are also very dangerous within the cylinder during the combustion. These are seen as exhaust smoke and causes undesirable odorous pollutants, because a lot of odor will be coming, bad smell will be coming, and a lot of smoke is coming. And because smoke is very dangerous, it automatically goes inside to the air and nose, along mixing with the air and all. And we are going to get the soot particles or clusters of the solid carbon sphere, and in soot particles will contains the carbon particles. These spheres having diameter from 9 nanometers to 90 nanometers, 1 nanometer to 10 to 9 nanometers will be having. The spheres are solid carbon with HC and traces of other components observed on the surface. A single soot may contain up to 5,000 carbon spheres, because in the smoke, each and a single soot of smoke, we can collect it and see it, and this will be having a number of particles will be 5,000 carbon spheres or carbon particles will be there, mixing with the hydrocarbon and all. Carbon monoxide and hydrocarbons will be forming like a particles and goes inside the uh, our system. Particular particulate generation can be reduced by engine design and control of operating conditions, but quite often this will create other adverse results. Particulate generation can be reduced by engine design and control of operating conditions, but quite often this will create other adverse results. Basically, design criteria we have a small modifications and small things we can do it, but conditions of the engine also very important, and what purpose you are using, what speed you are going, what load you are going, and how you are making the design, and what is the conditions you have to see it for these things. And engine management system are programmed to minimize HC, CO, HC, and noise, and the particulate emissions by controlling ignition timings, injection pressure, and injection timing and valve timing, obviously. Some sort of compromise is necessary. In most cases, exhaust particulates amounts cannot be reduced to acceptable levels. solely by engine design and control. Basically, you may be heard about Bharat stage 1, stage 2, stage 3, and stage 4. Now, every country, that is called European standards. Bharat, India will not have any standard limitations. Most of the countries will be following the European standard norms, pollution norms. And we are also adapting the pollution norms of European countries, and those the standard norms. Presently, we are following the Euro 4 norms. These are the very standard norms which we are going to reduce the pollutants, because a lot of electronics will be involved. While we are talking about the engine phenomena, we have the electronic ignition system, electronic control systems will be there. This will help us for the sending of the fuel, rich mixture, lean mixture, and how much quantity of fuel is required for what speed you are going, what road you are going. They're all will be calculated through the sensors, and it is given to the ECU unit, electronic unit control, and this control will help you to minimize the pollutants and pollution norms of an engine and these conditions. And that's why what happens, a lot of electronics are involving and a lot of controlling methods are using, a lot of sensors will be using in our automobiles to reduce the excess emissions. Only minimum quantity of emissions only can be reduced. I talked about the engine design. If you have the modification of the engine design only, you are going to get the Euro 4 norms. That's why every vehicle cost has drastically increased in the last 10 years to improve the quality of the engines and all. And a lot of electronics is involved, and a lot of optimization has come up, the mathematical optimization, engine management system and all, and that gives the good control of the pollution. And other emissions, apart from the major emissions like unburned hydrocarbons, carbon monoxide, and NOx, there are other emissions that come out of the exhaust. These aldehydes, sulfur, lead, and phosphorus. There are aldehydes also will be coming. Sulfur is also coming. Sulfur is also dangerous. And lead also I discussed. Lead content still it is there in few percentage in the petrol content, and these things that is also dangerous. Still we cannot remove everything, but few 1 to 2% or less than that, we are having lead content in the petrol, and phosphorus also will be there. And because of the combustion reactions, are going to get these different pollutions and all pollutants. Okay, next class we will discuss about the emission control methods. Any doubts? Any clarifications? Hello, friends.
Can you please elaborate about photochemical smoke, sir?
Huh? Say loudly.
Sir, can you elaborate photochemical smoke?
Photochemical and smoke. Okay, next class we will discuss it elaborately in photochemical and all, what reactions we have. But I have my own restrictions because I am not a chemical man. But whatever thing will be available, I will share to you, or I will share with you.
Okay,
Photochemical
sir.
reaction will be there. The reactions also I will show the next slides. Anything?
So can you give info about the minor exams?
Minerals.
Minor exam.
Minor exam. Actually, today I want to post in two-stroke engines we have some problems, and supercharging also has some problems. 10 problems I will give with hints and all. And today I upload these things, and you can solve these problems and submit it. And if you are having any difficulty after 10 days and the next week, or I will give 15 days time, then we'll discuss about the problems. First, I will give the hints and the problems will be loaded, and you can try it. If you have any difficulty, we'll explain one by one. Okay. But about the minor, we have not got the schedule. No? You got the schedule?
No, sir. It's
No, sir.
it's faculty wish, sir. We can
Okay.
put anytime.
Okay. Anyhow, after posting of this today, and tomorrow we'll plan it. Tomorrow I will announce the date of the minor.
Okay.
Even your PPTs will be posted in LMS also.
Yes.
That only the media where we have to have an examination, no?
Yes, sir. In
Anyhow,
LMS.
we will plan minor exam as a objective type only.
Okay, sir.
It's a completely objective type and based on the basic fundamentals, not all the syllabus. Okay. Tomorrow I will announce the syllabus also for the minor. Because already you are in very good head of the syllabus. Then anyhow, I will decide the syllabus of the minor. And most of this object type only. Anything else? Hello?
And I guess no doubt, sir, we can leave.
Okay.
Thank you, sir.
Okay. Thank you.
Yes.
Thank you, sir. Thank you, sir.
పెట్టుకో